Good afternoon. Welcome to the Veritas Automata Deep Dive. I'm Ben Savage, the CEO and founder of Veritas Automata, and I have Saurabh with me as well. So what are we going to talk about today?
News, the new GPUs. So what do you think about that, the H100 and the B200s?
Well, and the H100s have been around for a while, right?
Yes.
But I think what we were looking at that was interesting was just how much difference that you get. Because in some cases, you think about the memory difference between the two, right? The H100 has up to 80 or 90 some gig, and then you can get 2 or 3x that on the H200.
Right.
But one of the papers that we were reading recently was talking about not only do you get the additional memory, but because the CPU architect, the GPU architecture is different between them, you can see some significant performance differences in like startup. I think, it was like a tenth of a second to almost a half of a second faster to start to first token on the H200 in some scenarios than the H100.
Yeah, and I think they changed it from single die to dual die with the new models, right? I think most of but their power output is also slightly higher, but not double. The H1 was 800 and this was like 1,000, right? So, but if you're getting 2x or 3-4x performance out of the same card, your carbon footprint or the energy requirements are really low with this. So it's an exciting card especially for the inference mode, I think, where you can hold massive models on a single GPU without having to spread them.
Well, and I think can you hold the model? But I think there's a whole other thing, and this is something we think about, right? Because we've talked about a little bit that we've built our own GPU server. Right. I think as you're looking at how you go build your workflows and your pipelines, there's do I put it in the cloud? Do I buy hardware? What hardware can I get? And then I think another thing you almost need to think about is how do I build my dev or my prototyping environment so that I can safely go run a bunch of iterations and maybe have something go off the rails and not wake up with a whale of a bill.
Yeah.
And so you've got to understand some of those trade-offs. It's like, okay, will I make it work? Am I building something else and that could be a risk or not?
Yeah, building on that, right? You mentioned that it has a faster boot up time, which is
faster time to first token.
Correct, the boot up of a model, right? So think of like local LLM models if you're running, and if you have multiple of them, right, and it's agentic and it's kind of choosing which model to pass it through. If it boots up real fast, I think it will make the overall inference time really low, because even the faster GPU, the first token takes a while to load, right? So if you can reduce that, now you can switch between multiple models, get the benefit of different models, and yet have the seamless experience.
Well, and that was one of the things that surprised me in the paper about the article about the B200s or BH200s was that they had multiple FPs, right? Because we think about when we talk about running models locally, a first-class model is going to run its FP8. Is what they normally optimize.
Right,
that's
1632-bit,
and that's what
precision,
and that's what the H100s are optimized for. But the B200s can run FP8, FP6, FP4,
right?
Meaning that you can run quantized models and still get a performance boost on it, which that to me was very interesting. As we think about that, and now there's a trade-off. I think we've talked about this a little bit in the past, but sometimes those quantized models, you lose either some of like the tool use, or you lose some of the guidance or the steering, or you can get some other behaviors. But knowing that you can pick up a massive speed boost with that, it's something to consider.
Right. Quantization is really a fun thing to do, but again, it's a bit hard to fine-tune a quantized model versus a full precision model. But going back to the GPU thing, I think this build is mainly focused towards inference population, right? Where you probably need a larger cluster of H100s to train your model, but when you're ready for inference, these will be really go-to GPUs. I didn't see a pricing on that. Do you have an idea what it might be?
They're in the same range as what the H100 used to be. That's come down, right? Because it's 2 generations old or now.
Gotcha.
So the B is the new. So you're in that,
right,
30, 40 plus range. Per card. But of similar memory now is the new RTX Pro,
right?
Which I think we'll look at for our next GPU server, which gets you an NVIDIA-based architecture. It gets you the memory to run the model, but you may not have all those CPU optimizations or some of the pure CPU performance or GPU performance.
Got it. So for our purposes, probably those would work well because we do inference as well as fine-tuning and training from scratch. So it helps quite a bit on that front as well, right? Yeah. So beside the GPU, I saw that interesting.
Well, before we get to that, just thinking about architecture and stuff. Remember the project we were working on for the embedded system where we were doing the model, and you were using a format I wasn't as familiar with, the Onyx format, to do that.
Yes. So the models are underneath all weights and biases, if you think about it, right? So a bunch of them. Now they come in multiple different flavors. Keras is one of them from TensorFlows, have their own native one, and then TensorFlow Lite, Onyx is one of the other ones, right? So when we go down to running them on the edge on various different devices, right? Maybe ARM based or one of those Jetson based and all of those things, right? So each of them, since they are very, very small and specific, their tooling sometimes supports some of the models and sometimes they don't. But it is possible to take, let's say, TensorFlow build models, or even the what's the I'm kind of drawing a blank, but from the meta side of the world, right? Take the model and convert them over to either TensorFlow Lite, Onyx, or even other different formats out there that you can use, right? So it can run. It's just that they are packaged in it differently.
Well, and we ran into some CPU issues, right? Because all the initial work was done on x86 systems,
right?
And then when you're moving over to the ARM with the TensorFlow and the particular, I'll call it, machine learning stack that they had, we ran into a couple of things where the way it was processing, the way we had trained the data and the way that processor worked, created some conflicts where it was just running way more clock cycles than we expected.
Correct. Yeah, I think it was very hard to decipher the problem. Yeah, you were correct. We were trying to run this. It ran really fast on a x86 based architecture, but as soon as we moved on to an ARM architecture, and it was one of the steps where we were kind of slicing the image down to do something with it, and that's where it was bottlenecking like heavy, right? And it was not the model in itself, right? So we had to creatively figure out a way to embed that whole process in the model and all of that stuff. But it was an adventure for sure, especially it was fun to see how LLMs start to fail on the edge cases because it doesn't have enough data on that. Because we did use public LM to debug it, and it was not going anywhere, right? Only when we got an expert who has spent decades on embedded system, he could maybe that piece where it's moving from buffer to this. I'm like, oh, okay, maybe let's try that out. Kind of highlights we kind of ran into the edge of an LLM.
Well, it highlights one of the things, and even in normal computer science, it's not, most developers don't run into that problem, right? Most people are working on one CPU architecture or one system architecture. And then when you start going between an ARM and an x86, they've got different significant bits, they've got different cache sizes, they've got different ways they handle floating point math. All of those things can really impact how your program runs. So just because you make it run in one environment, just because I make it run in ARM, doesn't mean it's going to work well on x86 or vice versa.
Right.
And I think that's also kind of what NVIDIA's secret has been, right? They've built their CUDA library, which works really well on theirs, and nobody's quite matched it yet from a GPU perspective.
Yeah, I think those optimizations are really, really down at a low level, but those are required when you are really working with small CPU cycles or need things done real fast, right? I think that's a skill that's not enough information out there for LMs to understand and run with it, for sure.
So where were you going with your next question?
I was going into the Sonar paper, which came out, because it was very, very interesting to read, right? So we have been talking about vibe coding and code generations using LLM, right?
And the whole paper was reviewing the different models to figure out where they might fit in the real world from a career perspective, like at a skill level perspective.
Yeah, absolutely. So, what I'm seeing more and more with, Claude and the GPTs and some open source code development, it has become really, really easy to prompt it, and it writes you the entire stack. And sometimes they have agent mix on it. It writes you files in your folder itself, right? But what the paper covered was in a different aspect, not on the accuracy of it, like how it is doing. Almost everybody can meet the end goal, but what about complexity, lines of code, documentation?
And where in a development process or a product life cycle do these models fit best?
Correct. And those are important questions, because if you really get a prototype out there and you put it in production, then there is a glaring security flaw in it, right? And one of the things they pointed out that almost all of the models that they covered or studied had a very lack of emphasis on the security of the code that they were generating, right? They were really trying hard to get to an output without really considering a lot of the other aspects.
And that security could be everything from using hard-coded passwords and credentials to things like calling libraries that don't exist, which set you up for a future attack where someone can go populate that with a compromised package, to just generally bad coding practices.
Yeah, absolutely. And so they assigned interesting characteristics to each of the model, which was fun to read. I think the Claude 4 they assigned as senior architect.
Yeah, Sonnet 4 was a senior architect.
Yeah.
OpenCoder, which is an open source model, they kind of said was the rapid prototyper.
Yes. And then I think GPT was
GPT-4
generalist.
was the generalist, right? And then
Llama 3.2, I think,
was the
promised undelivered or something.
Highest, yeah, it was the highest expectations but least delivered, I believe, or at least met, and which is unfortunate because there's some things I like the Llama model for, but
yeah, I can see that. I've tried almost all of them, and even calling the Sonnet 4 senior architect, it's pretty good at doing traditional IT stuff like CURD and front end and all that stuff. But I found it to be a little behind. And again, this is my point of view, nothing tested or benchmarked, but I found GPT to be more better at ML short of things because I feel like it understands the stats and the underlying algorithm better.
Yeah, I've seen some weird things. So one, so everyone understands, this paper came out before GPT-5 came out.
Right.
And you got forced to GPT-5 in your chat?
Correct. Yes, I did not like it that much, but I mean, yes, I was forced into it.
But I've seen a couple of articles, other articles that people are claiming that GPT-5 is a better coder than GPT-4 was. I'm not sure on that. So like I've successfully failed to vibe code a number of things where I either am asking something too complicated or not breaking it down, and I get stuff that doesn't work. But I had an interesting experience. I was trying to build just a quick Gradio web page to back up from an API to download a bunch of files from a service that we use. And GPT gave me something, and it kept giving me an error with an open quote. So I had to go figure out where it was screwed up and fix that. Realized I need to have some improvements, so I asked it to go modify the code. And it was interesting. There were some times where it would give me something completely different back. Like it would lose the whole plot, like the ability for me to enter the API credentials that I needed. It would all of a sudden forget it. And it's like, you had that in the last version. How did you lose that in this version?
Yeah, I've seen that happen with GPT often, and almost like you have to run the memory notes for it and then plug it back in. Hey, did you forget it? Or kind of purposefully prompt, make sure you preserve all the features and not take the shortcut kind of a thing, right? So yeah, going back to that whole aspect of, I found GPT, maybe it's been around for a longer period or whatever database it used to train. It had little bit better grasp at statistical concepts, and like I was running some of the analysis on wait times and things like that. It actually pulled theory out to say this is why I did it, versus Claude was like, nah, here's a simple, do some averages, multiply this and do this and that, there you go, kind of a thing. But it was kind of interesting because Claude is generally really powerful and writing out code, and and that runs first time, very surprisingly. So that's something to consider. But beside that, vibe coding, in my head, I think I got a good idea of what vibe coding is. It's an automation tool, but you still need to know what you are doing. It just accelerates your process, or else you won't be able to catch those gotcha, you took a shortcut there. It doesn't make sense, right?
Well, it's being able to review the code, it's being able to fix the stupid stuff it does. I think that's all important. I think the other thing that's important as you go through some of this is really you do have to, at least at a high level of an architecture, and build those requirements right that you're going to have it go build from.
Right.
If you don't get that piece right, then it goes off the rails. But that's where whether it's what Amazon's trying to do with their Kiro tool, where they're calling it spec-driven development, or like Taskmaster out of Claude, or the way a lot of those tools are approaching it, where you can build a set of requirements and then work against them. I think that's all very interesting. I think that's going to be a part of the final solution.
Yeah, I think their approach is kind of good because they are writing down a to-do list, which I was saying I'm writing it down for it, right? And then my problem with that is what if it forgets the to-do list in the context? Because often if you're dealing with code bases which are maybe 200,000 lines or whatnot, right? It may not hold everything in memory and then lose the to-do
Well, I think
list.
that's why that to-do list or that
Yeah.
task list or that product report, that's got to be a separate document.
Mm.
It can't be just in context, right? It's got to be, you tell it, well, let me phrase that. It's something that it has to include in the context, but it's got to be something you tell it, hey, go look at this. So that way, if it loses or you need to start a new window, a new chat,
Yeah.
you can go back and say, here's the code, here's this,
Mhm.
here's these other things, pay attention to these, and then go do my
Yeah,
request.
yeah. So we'll see how that whole architecture of attention network works, right? So how can we emphasis to put more attention on certain aspect and let rest of it kind of evolve, right? Kind of a setup. So I think the code generation piece will evolve as we kind of go
Yep.
through the phase, but it's interesting how that's evolving. All right. So I think we wanted to cover a few more interesting ideas, right? On what was the thing we were talking about? I'm drawing blank right now. So the IBM paper on the abnormality detection.
Oh, yeah. That was actually a video, right?
Yes.
That was one where, because
Yeah.
your background is fraud detection
Right.
in financial institutions.
Yes.
And we apply that on our own to different tools. And this was an interesting idea in a video from IBM that came out this morning, actually,
Right.
where they were talking about mixing conventional fraud detection and
Mhm.
anomaly detection along with a large language model. And how do you build that loop to try and catch things even faster?
Yeah, it was very, very interesting because they started off saying that we got to catch this below 200 milliseconds or something. So they are working with a very tight inference window. They can't just throw every possible model out
Yeah.
there and take a minute for it to come back. So the paper discusses something very interesting, which we have done in the past and found it to be interesting as well, was use traditional models as a first pass and then assign how risky it is or
Yeah.
whatever target you want to do. And if it is uncertain about certain things, then bring on the big guys, which is unstructured data with language model like BERT or Roberta or
Yeah.
even a small LLM model to extract certain things. The things could be like urgency, right? If somebody is requesting for wire transfer and they're flagging, hey, this is
Yeah.
very urgent or whatnot, and I mean, the situation that's suspicious, versus a traditional business transaction.
Well, and that's something that might not come across in a conventional detection because it may look like conventional language,
Right.
but because of what you can do because large language models are so good at understanding language itself,
Yeah.
it can pick up some of those patterns that you couldn't really hard code in a traditional algorithm.
Correct, because those traditional models are pretty much tabular, right? So you can use some of this language model to create data for the traditional model to use, like a flag, which is a binary
Or
flag.
like a set of rules.
Set of rules would be great. We can talk about that project as
We
well.
can talk at a high level, but
Yeah.
what was your experience? Because that was one of the things we were talking about, I guess it was Monday evening, right?
Yes.
That you've used a new tool. I think you're using a large language model to generate all these rules.
Correct. Yeah.
And then the question is, okay, which ones have value and which
Mhm.
ones don't?
Yeah.
Because you had how many rules did it create?
More than 200, but it was almost a million transactional records, and we were trying to find, is there anything interesting in there, right? So and the LLMs are pretty good at looking through all of that data, log data, and the transaction tabulated and coming up with rules. What's the association between this and that and this and that kind of a thing? And it would come up with association which are very obvious and doesn't need to be rule. Like if you are in Cincinnati, your state must be Ohio, or something like that,
Or
right?
like this ID is this ID in the record in the data set is tied to this ID.
Exactly, or something like those. So the culling process of it, what we used was an LLM to kind of look through common sense wise and check out some of the rules. So it took us a while to generate those rules. Now it's in the process of reducing it to top 20 or 30 or rank ordering them. Once we got that, we are using traditional tools to deep dive in those pockets to see, hey, what's the variance look like around this data point? Whenever you see this value tagged to a very high, what other events are happening at the same time? So again, we can look through that much amount of data manually, but using a bunch of different tools in a discovery mode and have a coordinator on top of it supervising and saying that doesn't make sense, that's an obvious correlation, drop that rule kind of thing. I think that's going to be an interesting, we might bring some of the findings to the podcast later down the line, but
or we can use some of those sample data sets where
yeah.
we were playing with the MCP and the data. We can run it on those and run the same process. But
Yes, because I've seen a lot of tools out there to catch traditional like outliers and things like that, but they are not very holistic. They are looking at 1, 2, or 3 different dimensions. But we were thinking against, this categorical variable under that, under this, and that's when it's happening. It becomes very, very narrow, like almost like going down a tree and picking that. You are doing some kind of analysis on it. So it was an interesting exploration effort, and we were tanking out, we were loading up our GPU server pretty heavy to do some of the analysis. But again,
you said it was only one card. There's 2 in it.
Yeah, some of it was going through GPU enabled algorithms, somewhere just CPU heavy, and we were eating up a lot of RAM and all of the stuff, right? So it kind of also begs back what kind of setup we are building, right? If you are building a GPU server, what you have been in building computers forever, I'm guessing, an enterprise grade computer.
It really depends on the workload, right? That's where you gotta kind of understand, and that's what we talked about when we built it. Is it okay? Am I limited by clock cycles? Am I limited by I/O? Am I limited by memory?
Right.
Where are those limitations? And even as we've played with some of this stuff, some of what you find is that the existing tooling may only take into account 1 GPU, even though you've got 2. It may not be using both, which is like, okay, well, is it really worth having the second one?
Yeah.
So I think that's all stuff you've got to go and optimize it for that workload. And then the other thing you've got to think about is like, okay, what type of memory, right? Because now I can get the fastest memory, but maybe that's not error corrected.
Yeah.
And some of the research I've seen, at least for large language models, and I'm going to train even small models, error corrected memory can be important in the consistency of the model.
Yeah.
And that if it doesn't have it, that you can get weirdness.
Yeah, you can get a bit flipped because of a slow solar flare somewhere. That might happen, right? The other thing people often ignore is the power, because if each of these cards are very, very power hungry, and you only get up to 1600 watts of a traditional power output.
Well, that's for a power supply unit. But if you're putting it in a data center, so like one of the buildings that we work out of has an old data center in it. Each rack could only support 2.5 kilowatts of power. Well, the problem is I can support 1 of the new GPU servers because those are going to be using a 1600 watt power supply. Yeah. So I'm at 1.6 kilowatts there for that. It's like, so I can have in this room that's probably 40 by 50, and it's got 5 or 6 racks. It's an old data center. It might have more than that. It might have 10. I can fit up to 10 servers.
Sure.
But it doesn't have the power or the cooling unless you massively upgrade it.
But this building your own workstation with this high-end GPU is a fascinating world where you have to balance cooling, power, PCI lanes, how many you got, and what's the gapping between
physical space.
So it's a fun. It brings back memory when we're building computers, right?
So back to I just want to go back to when we're talking about training models. Did you see the news about DeepSeek R2?
No, I haven't seen that.
So R2 was supposed to come out in May. So they released R1 back in like December timeframe, right?
Right.
And then I guess they were trying to not train R2 on NVIDIA GPUs, and they've had issues. They actually, I think I saw an article this morning that maybe they had to switch, but it's basically been delayed because they weren't running on some of the NVIDIA training setup.
Yeah, it's probably one of those new architectures issues with maths and all of this.
Well, and those guys had done some stuff. It's the one thing people I don't think gave DeepSeek R1 credit enough for is like they didn't use some of the CUDA libraries. They did their own assembly to optimize and speed up the training of that model to be more efficient on the cards they were using. Well, so they took some things that are a little different, right? The rest of us have been kind of cruising on easy lane and just buying more hardware. And they had some other limitations.
Yeah, I think the optimization will become more and more relevant, right? So we're just waiting for more open source CUDA equivalent. Who knows?
So as we kind of wrap up, any other favorite news or favorite things you're working on right now in the AI space?
No, what I'm seeing more and more is the video generation models are getting better and better over the time, right? So I'm hoping to see that it goes beyond 10-20 seconds to a longer time frame with mixing storylines and all of that thing brought in, like mixture of expert setup, but for video generation.
Yeah, I'm excited about that too, but I don't know if it needs to really go beyond like 10 or 20 seconds. But at some point, you're going to have to create the tooling where I can build my story out. And then just like I would for conventional video or production, I can build my storyboard and say, okay, these shots are going to happen here. Then I can make it much easier to do that. The dialogue is continuous, but the shots and the generation can be in shorter because I'm cutting between different perspectives.
Gotcha. So basically changing scene over as they do that. That might be a way to do it for sure.
Well, and there's been a whole other push that I was looking at for a sister company of ours. They've been very interested in doing mocap for some stuff they
Right.
want to do. And some of that's come a long way in the last 6 months. Might take up some time on the GPU server.
That's always fun times to do with vision-based problems to solve for sure.
Cool. Well, I think we'll leave it at that. This will be a short one. We'll figure out some demos we've got to do as we come up in the future. Because I did send you a couple of new LLM games.
Mm-hmm. You did.
Like
Yeah, we
may
got
have
to
to
get
come
them
back to-
running.
we may have to come back to those. So cool. Well, I really appreciate everyone's time. Love having everyone here on the podcast, and reach out if you guys have any questions. So thank you.
Thanks.